Hello, this is my Modern Physics Lab 3, and this is exploring the motion of a star around a black hole. Uh, in this lab, we use the motion of a star around a black hole to calculate its mass. We then calculate our dp/dt, our change in momentum over a change in time from the motion data. We then use Newton's second law, which we can use to relate Fnet to dp/dt. And then we use Newton's law of gravitation using that Fnet, and we calculate the mass of the black hole, which I found to be 3.7890 times 10 to the 31st kilograms. Some equations we use in this lab is this Fnet is equal to the value of dp/dt. We'll explain exactly how that works later in the lab. We use our Fnet parallel, and Fnet perpendicular is equal to our Fnet, and then our change in momentum over our change in time is equal to our dp/dt parallel and our dp/dt perpendicular. This is Newton's law of gravitation. Fnet is equal to gravity times mass 1 times mass 2 over the magnitude of the unit vector squared. And to find the mass using gravitation law, you just use some algebra and rearrange it so we have this form of the equation. And now, to show how we coded, this is our mass of the black hole. Now to show how we coded all this, we get our initial conditions. Our star mass, 1.989 times 10 to the 30th, a delta T of 86,400, which is how many seconds are in a day. And then use this to calculate our velocity. We got our delta x by finding the change in position x, y, and then do delta x over delta t, which gives us our velocity by the change in distance over the change in time. The same thing for delta y. And then we have a list of our x velocities and our y velocities. We then use our main calculation loop. For v initial, you just plug in our values there, and then v final is going to be one more in the list. Then we can use that to calculate our momentum, which is of course mass times velocity. And then to find the change, we do the final minus the initial. We then calculate our dp/dt, which we then can say Fnet is equal to dp/dt because of Newton's second law. We then calculating our dp/dt parallel, we simply do this by getting our initial p over the magnitude of our initial p, finding the unit vector, and then we take the change in the magnitude of our momentum over delta t, and then we just multiply those together, give it direction. One of the properties of having Fnet equal to dp/dt is that Fnet parallel is equal to dp/dt parallel, and Fnet perpendicular is equal to dp/dt perpendicular. In the final perpendicular, we just take the overall and minus it from our parallel, which, as we saw earlier from this equation right here. Now, when we run that code, we get this model. And then, after we see the model, we can look at this is our time, this is our Fnet magnitude, which is what we're really interested in, and these are the two components that make up it. We then take that new magnitude and plug it in here for our Fnet magnitude. We calculated the position vector from the black hole to the star. You square that, and then we times that by our gravity mass, and that gives us our mass of the black hole, which we then calculate to be this, as we mentioned earlier. Now, what does it mean? So how is dp/dt different from Fnet? Well, Fnet is the cause of all these things. It is the cause of the change of velocity, which is the cause of the change of momentum, which changes dp/dt. The nice part about this is that we can say that Fnet is equal to dp/dt. But basically, our Fnet, our force, is what changes our dp/dt. It changes the momentum, it changes the motion. So our Fnet is the cause, and our dp/dt is simply the effect. And what if? What if our black hole was replaced by another of a different mass? Could we tell the difference? We could tell the difference because our mass would cause a change in the force, which would then cause a change in the motion of the object. That change in the motion, we would then use just how we did the motion in this lab. We'd observe the new motion and calculate the new force, and then use that to calculate the new mass. Thank you for watching, and see you next time.